Over to you, DC.
So it is difficult, to have politicians work with you. But unfortunately, it's not a choice. It's something that you must do. So thanks for inviting me. What I've done, because the topic is quite, it's a complicated topic, but as an engineer, you're always excited to just try something that sounds very difficult. So I accepted to speak on this topic, and I found it very intriguing in the sense that it touches on a lot of aspects that if any one of you wants to venture into, creating new industries, you'll be touched by most of these actions. So Nyanza Light Metals embodies Africa's industrialization aspirations. We founded the company in 2011. And we were focused on addressing the critical gap in mineral beneficiation by transforming ilmenite or heavy mineral sands that we find South Africa and Africa heavily endowed with. So those who are in mining or mineral processing, you would know of Rio Tinto, or in Richards Bay Minerals specifically. You would know of Tronox, so Tronox mines along the KZN sands as well. You would know of their operation in Namakwa. But all they do in those operations is mine heavy mineral sands, put it through material separations plants, have ilmenite, have rutile, have pig iron, and they export that into the rest of the world for further value addition. So in our case, when you take titanium dioxide pigment, which is the critical mineral we're after, you would take RBM or Tronox, or Kenmay up in Mozambique, they export that at a value of $300 a ton. Now, the question was, where is this going? And what happens to it when it goes there? And the reality is that we were quite struck by a stark reality that it goes to mineral processing plants that process this to produce what is called titanium dioxide pigment. Now, titanium dioxide pigment is the material that is widely used in making paints. So anyone who's making paints would know that about 60% of the cost of paint is actually driven by titanium dioxide pigment. Those who make plastics, industrial coatings, paper, inks, and also even in some FMCG applications like milk. Some of us grew up in rural areas, and we always make a joke and say, when we grew up, the milk we used to get was yellowish. But we come to Sandton or Johannesburg, the milk is very white. And we always wanted to understand, how come our cows produce yellow milk, and in Sandton there are these cows that produce white milk? That's titanium dioxide pigment. If you did brush your teeth today in the morning, just check your toothpaste, it is titanium dioxide pigment. If you did put makeup, these days everyone can put makeup, it is titanium dioxide pigment. So if you look at that, we said we're exporting. South Africa itself has got about 22% of the world's reserves of titanium dioxide. If you combine it with the rest of Africa, we're 45%. And yet we exported $300 a ton. And then we buy back the finalized or the value-added titanium dioxide pigment at $3,000 a ton. So we're only capturing, as a country and as a continent, we're only capturing a tenth of what we produce, the tenth of value of what could possibly be the value that we have on the continent. So that was the beginning of our story in 2011. Now, our story was wasn't straightforward. When you graduate and you have industrial engineering, you think you're the smartest person, and then you get an MBA, and then you think, okay, that's all it needs. We learned very quickly that while you're planning something, the world is also planning something. So there is no straight line in terms of what you're expecting out there. So when we started, we thought 2014 will be in production, 2015 will be in production. We only started construction this year in August. So 13 years, we have been dealing with navigating the industrial, the political economy, the technical space, the advancements in technology, and trying to figure out how exactly do we end up with a business that can compete in the future and not compete today. So the Nyanza story, I think why we want to talk about the Nyanza story, and I wanted to share this, is that there's also this notion that entrepreneurship is very nice. I think I was just having lunch with some of your colleagues here, and I was saying, once you're in, you have no choice but to keep pedaling forward. But those who are outside, they're kicking and screaming, trying to get into entrepreneurship. But it's not as straightforward as it looks. But once you're in, you must follow through. So we have gone through quite a lot of different experiences. We started off from our background as engineers. Some of us were fortunate enough after engineering and having run manufacturing operations, we managed to move into investment banking and development finance. So we had a bit of both worlds, and we were managing private equity funds, and we had the ability to connect the dots and say, we think we're best positioned to actually provide what we call early stage funding to drive or create a pipeline of new projects that would become the pipeline that leads the industrialization of Africa. What we didn't know when we started there was the impact of regulation. That's the political economy. We didn't know about the impact of communities. We didn't know the impact of the global economy that is transforming in itself, making certain technologies, certain products irrelevant in today's term. So I think maybe just to close off on Nyanza as a story, today what we're building is a project that will make 80,000 tons per annum of titanium dioxide pigment, which is the high value added product. The cost of the project is about $860 million. I think in today's exchange rate is around about 15 billion rand. The bulk of that, if you look at the financing of that, $550 million of that is capex. And then you have interest during construction and working capital, making the peak funding $860 million. Now, if you take our plant and compare it to what we see or comparable plants outside in US or in China, you would find that their capex ticket is probably almost half the size of what we're doing. And part of the reason, again, it speaks to the whole issue about industrializing Africa. In Africa, in our case, even though we are in an industrial development zone, we had to also factor in building our own utilities. So when we look at our competitors in Leverkusen or in China or in USA, they go into an industrial park that actually has power, that has water. And when we talk water, we're not talking clarified water, we're talking demineralized water, which you can actually use for your process. They have compressed air, they've got steam, steam boilers, they have all the utilities that you need, and you just buy all of this over the fence. In our case, we have to build this together with the main plant. So about $250 million of our capex is actually just aimed at bringing in these utilities and infrastructure. So that's the burden of Africa. And if you tie that together with the burden of lack of deep capital markets, so financing costs, you'll find they're generally much higher than the financing costs you would experience in the US or other advanced economies. All of that adds up to creating a situation whereby it becomes a barrier of entry or very difficult for many other projects of this nature and scale to come into line. So anyway, that's just the story of Nyanza. And I thought those are some of, I don't know if I've spoken well around his insistence on me talking about Nyanza, because I thought we were talking about something else today. But industrialization is paramount to what we must do. It's very important that we were able to create greater economic resilience by freeing ourselves away from just being a mining or mineral commodity exporter. When you do value addition, you actually create domestic mineral value addition jobs that are of higher quality than the jobs that you might just find in primary mining. And most of these skills you'll find when you do value addition, it's not necessarily about titanium, what we're doing. We've built in a capability that says we are able to transform minerals into high value added products. One thing I didn't touch on Nyanza there was, while we produce titanium dioxide pigment, we produce a byproduct called copperas or iron sulfate. And this is, while it's used in industrial effluent treatment, it's at low value, we produce this byproduct in quite huge quantities. Now, in the past, before the energy transition story had kicked in, this would have to find its way to the landfills. Now, what has happened over the last 10, 15 years is that because of the emergence of critical materials or energy transition materials, like lithium iron phosphate, the copperas that we have, which is the iron sulfate, is a primary raw material in making lithium iron phosphate. So you will see when we talk about Nyanza, we talk about producing high performance specialty chemicals like titanium dioxide pigment, but tied into that as part of our circular economy emphasis to make sure that nothing leaves the plant as waste, we end up producing lithium iron phosphate. So we have iron sulfate, we bring in sulfuric acid, which we already have on our plant. We bring in a phosphate rock, which South Africa is endowed in. You react that with sulfuric acid, you have phosphoric acid or high purity phosphoric acid. When you have that and you react it with our iron sulfate or copperas, you have iron phosphate. Now, that's the first stage critical material in your cathode or as your cathode material for your electric vehicle or battery storage systems. And after you have that, you can bring in lithium carbonate, lithium oxide, or lithium hydroxide, depending on the cost structures of where you're sourcing it from. And then you calcine that together to make lithium iron phosphate, which is the primary material used by Teslas, the BYDs, all of these guys who are making electric vehicles. So what you do coming back to the story of Nyanza, again, what I was trying to say is that when you start moving into value addition, you are moving into a space where it's not necessarily about one component or material or product. It's more about capability to transform basic raw materials into high value added products. So for Nyanza, I promise now, let me stop there. I think I've shared quite enough. I wasn't planning on talking about all of Nyanza today. But coming back to our topic today, I think what we've seen with the Nyanza Metals project, in my case, is engineers play a vital role in driving industrialization. Engineers and technical professionals are the bedrock of industrialization, transforming discoveries or scientific discoveries into economic growth. Nations like China, the United States, and South Korea demonstrated the pivotal role engineers play in driving industrialization. So I'm saying this to try and remind you that any industrialized or developed economy, it starts with engineering or technical proficiency and capability. So that's why you would find some of these nations that are advanced, like the South Korea that transformed itself from a war-torn country into an advanced economy. They invested largely into STEM, science, technology, engineering, mathematics, to drive or to create the capability to generate these ideas. So everything with industrialization starts here. And sometimes maybe we don't see it as engineers that this is where the story starts. But today, what I want to connect is what else do you need to do? Because most engineers, even in some cases myself, we felt lost at some point, thinking that every day you generate ideas and they play around with them, you park them there. The politicians don't care, the communities don't want to listen, all of those things. But it starts with us, and we have to take ourselves out of our comfort zone and start looking at how we influence the economy to take up those projects. If you look at, I think I wanted to touch on, I had quite some examples that I'd put here, but I've spoken about the United States technological dominance, which was attributed to a huge engineering tradition, and South Korea's transformation. We know the electronics manufacturing with the Samsung, LG, the automotive manufacturing with Hyundai and Kia, and shipbuilding and maritime that the South Koreans dominated. China, I don't have to talk about China. I mean, China is pretty much dominating everything they get into. And if you look into Africa, and then the question is, what are we dominating in? We seem to be continuously being a provider of base resources, and we just continue to deeply invest in that. And what it means for the broader economy is that even the technologies that we're trying to invest or bring into the country, they continue to be determined or defined by the primitive industries that we continue to hold on to. Now, the next pillar, is about capital markets and industrial financing and how it's very critical, especially for industrial engineers like you. One may say that it is all well and said that engineers must do all the above. I mean, this is quite a lot for somebody to do. But the challenge is that there are many other challenges that are outside the control of engineers. This brings me to the point around capital markets and industrial financing. Effective industrialization requires more than engineering expertise. It demands access to capital and strategic financing. Capital markets and industrial financing play a vital role in bridging the gap between innovation and scale. In Africa, project preparation funding is critical to support projects from bankable feasibility stage. Institutions like Afro-Exim Bank, the Africa Export-Import Bank, Africa Finance Corporation, the IFC, Development Bank of Southern Africa, and the IDC, they have put together what we call project preparation funding facilities. And these facilities they earmark or target projects that are in their early stage that have capability or propensity or potential rather to be taken up into production. The challenge is always, how do you take that money from them? Because it seems very difficult to take. If you look at the South African government through the Department of Trade and Industry and Competition, the DTIC, some of you might know it, offers incentives and feasibility study funding as part of their industrial financing strategy to promote new projects. Nyanza Light Metals, as an example, its progress showcases the power of collaboration. Our journey began in 2011 with self-funded concept studies, followed by attracting institutions to support project preparation and feasibility study after completing the pre-feasibility studies. Securing funding for feasibility studies is challenging due to limited capital willing to take early stage risk. However, I think strategic partnerships has helped us overcome this hurdle. So in 2016, the Department of Trade and Industry, having seen what we have done and how much we had spent ourselves in feasibility studies, they came on board and started to match whatever we put in to take the project to the next level. Because we had the DTIC and we managed to de-risk the project by further defining the business plan, by further defining the technology or how we're going to build it. In 2021 and 2022 subsequently, African Export-Import Bank and Africa Finance Corporation joined the core development partners. And they took over the metal to say, because we are putting in funding to take the last mile of your feasibility studies, we will lead with the raising of the $860 million with their own $300 million commitment within that package. In 2024, the IDC also this year early also joined. And being a South African DFI, it was quite, we get into meeting rooms with the presidents, with the ministers, and it's all multilateral finance institutions from abroad that are sitting at the table developing a project in Richards Bay. So we're very humbled by IDC coming on board. Now, when raising project finance, understanding various financing options is very vital. Financial mandates and prerequisites are very important to understand. You have to tailor your pitch to the story. So you must always work backwards. Sometimes you must forget your technology. You must always say, for these guys to give me money, what is the story they want to hear? If you're not able to do that and you continue to punch your idea, you'll get frustrated. This is the art of the sell. Cash flow profiles are very important. If your cash flows are very quick, if you're doing a tailings dam recycling or you're doing some widget manufacturing and in 6, 8 months, 12 months, you have cash flow, that calls for a different bank. But if you're doing a greenfields project that says you're going to run for 4 years, just sinking money, then after 4 years you stop the bleed, you start producing some revenue, then maybe after 8 years you start seeing some profit. That calls for a different financier. So you can't have the same pitch to everybody because you run the risk of overselling or having your project on everyone's desk and yet it doesn't fit or speak to their needs. Private equity and commercial banks need quick cash. They don't like this long-dated risk profile commodity things, unless if it's a power purchase agreement where you're doing electricity or utilities, they would look at 15 years. Otherwise, 7 years, it's a hard ask or hard sell. If you're doing a project like mine where a tenor, minimum tenor, you need 12 years on senior debt, you need 15 years on mezzanine finance, forget private equity and commercial banks. You must look at DFIs, you must look at multilateral finance institutions to give you that. The contracting model is very important. I know as engineers, when we started, even some of our colleagues, because we thought we know engineering, we kept on analyzing, saying it costs cheaper if we build it ourselves rather than going to an EPC contractor. So your contracting model decides or determines who's going to finance you. So if you're doing a large project like ours and then you're doing an EPCM and you don't have a balance sheet to support or continue to throw money at it, there's no one who's going to touch you. So you have to go with an EPC kind of structure. So you need to understand your contracted model in the sense of the quantum you're looking for, in the sense of the cash flows and the capital markets or the banks you're speaking to. Offtake agreements also are a nice way of source of funding. If you get good offtake agreements with quality off-takers with a credit rating, if you're lucky, you can actually approach some traders or some banks for pre-production finance facilities. So these things, the reason why I'm listing all of these things is I'm trying to bring in the story of capital markets because as an engineer, sometimes we are so stuck in our own engineering ways and we forget to understand how to go and get the money to make sure our idea is funded. Others, generally, there is also some, listing is another example. People get excited about listing. I'm not a fan of listing. Listing is not ideal for Greenfield's project because of its stringent obligations and conflicting stakeholder expectations. When you list, a stockholder is looking at dividend yield every quarter. So they're waiting for your quarterly earnings results. They're looking, if there's no dividend yield, then the next question is the capital growth. How fast is the share appreciated? Now, we're not in the US where things continue to make losses for decades and the share is just rising and rising like the Ubers. We are in capital markets where it doesn't work like that. So when you decide to list when you're still in a growth phase, you might just be, putting the death penalty on your project because any excess cash that's in the business, stockholders want it swept out for their own reasons. So as engineers, we must grasp the capital markets to secure funding. We often mistakenly assume others will champion our projects or that technical excellence alone will suffice. However, visionary leaders like Elon Musk, whether you like him or not, he's a character. You must focus on his innovations. Mark Zuckerberg, Aliko Dangote, Strive Masiwa, they demonstrate the importance of deeply understanding and aligning with capital markets and the political economy. It's not like they enjoy having those dinners and suppers every day, but all they're trying to do is to influence and sell their projects and what they're doing to the capital markets. If you're not at the table, no one knows what you're doing, and no one wants to finance things they don't know. So their examples teach us that technical superiority is just the starting point. True success hinges on how well our ideas resonate with financiers' mandates and priorities. So that's on capital markets. And the last part I would like to talk about is policy and industrial development. So this is now more talking about the political economy. So we always shy away from these topics as engineers because we just hope that the political economy works in our favor. But the political economy has got actors in it. And us as engineers, we are not acting. So the resultant of what you get as a policy framework that's given to us to work within, the incentives, the tariffs, all of these things, they are defined by the actors in that political economy. So we've spoken about the role of engineers and capital markets in driving industrialization. If you look at the political economy, it is about understanding the complex relationship between politics, economics, and power. It's how governments, markets, and institutions interact to shape economic outcomes and distribute resources. As engineers and entrepreneurs who want to drive industrialization, we must consider the political economy's impact on our projects. We must understand how politics and economics and power intersect. This means recognizing the deep interplay between markets and governments, institutional influences or influencers, and global connections. By grasping these dynamics, we can better navigate the landscape and create sustainable projects. I'm quite fascinated by the background of most 18th century industrialists. And I enjoy watching, Netflix stories on people, the men who built, men as in not men in today's languages, just to be correct, but the men who built America. When you get into that, you find a thread or a theme of behaviors and characteristics and backgrounds. Then you start asking yourself, hang on, where did we make a mistake and find ourselves doing industrial engineering? I did industrial engineering, I'm just joking. So when I look at this 18th century industrialists, most of them studied political science, leveraging this knowledge to build vast resources or empires across politically charged geographies. Examples include Andrew Carnegie, my favorite, the steel magnate. He started as a telegrapher, then studied politics and economics, eventually dominating the US steel industry. John D. Rockefeller, everyone knows Rockefeller, the oil industry magnate. He studied economics and politics, navigating complex regulatory environments to build Standard Oil. We had J.P. Morgan in finance, educated in political science and economics. Morgan dominated corporate finance and shaped US economic policy. Cecil John Rhodes, Zimbabwe today, in South Africa, he was a governor of the Cape Colony at some point. Studied law and politics, using his influence to secure mining rights and shape British colonial policy in Africa. Mayor Amschel Rothschild, the banking, he combined banking and finance and politics to establish Europe's prominent Rothschild's banking industry. In Africa ourselves, we have our own Aliko Dangote, started business and politics, leveraging relationships to build Africa's largest cement producer. Now he's gone beyond and has done the world's largest single train in oil refinery. Patrice Motsepe combined law and business studies with political savvy to become South Africa's first black billionaire. These industrialists demonstrated how understanding political economy and navigating complex geographies can drive success. They understand that policy interventions are necessary for driving industrialization, and they actively lobby for desired policy. Export taxes or restrictions encourage local processing, while import tariffs protect local industries from dumping. So in our case, for example, I don't know whether I should be saying it here, but we had to lobby for an import tariff to protect in terms against anti-dumping from China, as an example. So there is now a tariff that will protect our titanium industry once we produce the first pigment in 2027. We're also lobbying for export tariffs to say if there's raw materials that we can beneficiate locally, why are they being exported without being used by a local producer? Now, this can only happen if we are active in the political economy. And if you look at some of the things that we're looking at, there's now tax incentives that are being muted for value-added mineral production. And being in the SEZ, we don't pay income tax similar to being outside. We pay 15% instead of 28%. So these are the things. Now, if you are producing or building together an idea, the reason why I'm putting all of these things is to show the interplay between your idea, what it needs to be sustainable, and the political economy and the capital markets, what all of these things need to come together for it to happen. So as an interest group of engineers, we must understand that we must play a vital, influential role in policy making for infrastructure and industrial development. Technical expertise is key in early stage project development and in implementation, and informs infrastructure planning, design, and project prioritization as well. But without policy lobbying, our ideas are likely never to see the day of light. In my conclusion, often engineers feel frustrated and hopeless when their projects fail to secure financing. I've gone through this a couple of times, but I keep on trying. But I know the feeling. And we're always blaming the financiers or the politicians for lacking vision and understanding. However, a critical element is frequently overlooked. It's alignment and effective packaging of our projects with the requirements of the capital markets and alignment with the broader political economy narrative. Africa's industrialization is our generation's urgent imperative. To achieve this, engineers, policymakers, and financiers must unite, recognizing the intricate dance between technical expertise, economic viability, and political will. The pioneering example of Nyanza showcases the transformative power of intentional alignment between engineers, entrepreneurs, capital markets, and the broader political economy. As we forge ahead, let's remember that effective packaging and alignment of our projects with the capital markets requirements and ESG considerations are very crucial. Misalignment can be fatal to innovative ideas. By embracing this synergy, we will unlock Africa's full industrial potential. I'm grateful to the event organizers for allowing me to come and share my few thoughts. I wouldn't have said no. I was already persuaded when I saw it saying Southern African Institute of Industrial Engineers. I just felt as one of you, it is my duty to also be here. So thank you very much. Thank you.